And so you will present, or Hari is presenting, or you will continue? Okay. So it will be presented by Pouya. He's currently a PhD student in our group. His research interests are algorithms and distributed systems, HPC and profiling tools. His work primarily focused on scalable and real-time analysis, monitoring and profiling tools, and then use them to solve the bottlenecks and optimize MPI library and applications. So in this talk, he will present a tutorial and also a live demo on the INAM tool, which he has been contributing over the last several years. So go ahead, Pouya. So you will show it from there or here?
Does anyone have HDMI converter to USB-C?
I have one. I think it should work.
So thanks for coming and listening. So the challenge that we see with a lot of like HPC communication libraries and like communication stack is how can we visualize, profile, and also correlate network activities across different stacks of HPC together. So this presentation is to target understanding that in real time. So let me start. This is the overview of what I'm going to present. Also, I'm Pouya Kousha. I'm a PhD student with Dr. Panda's group. So on the high level, we have more number of HPC users utilizing HPC resources. At the same time, we see more complexities being introduced in terms of new technologies, new communication middleware, new accelerators, that it makes it harder to identify if you have a performance bottleneck or if you have performance degradation, where is that coming from? And as the HPC system sizes are growing, you are hearing like 8,000 nodes, 10,000 nodes. So this becomes even harder. How can we have a real-time system-wide profiling of communication? And users expecting more like real-time and scalable solutions. So there are a plethora of HPC tools. These are the layers in HPC communication. So on the top level, you have the HPC application, then job scheduler, then your communication library, for example, MPI, and then you have the fabric. So understanding the communication across all of these is important for not just the admins, but also for the users, for tool developers, for like MPI developers. So among these HPC tools, we have some tools that provide some system level profiling, and some are user level. So for example, Tao is a user level because you have to attach it to your job and then run it. And then on the other side, we have tools like XDMod that is gathering system-wide profiling information. So with these different layers to profile, and there are different tools that collect from these layers, the problem becomes how can we correlate the activity across all of these layers, and how can we have a fine granularity? So how can we have a holistic, scalable, and real-time profiling tool collecting information from all of these layers together? So that's why we have introduced OSU INAM. If you see, these are a summary of the profiling tools for communication. and the different layers that they target. So OSU INAM on the top targets the interaction of application with MPI runtime, network and MPI runtime, and job schedule and MPI runtime. So to this extent, it's providing the full stack profiling of communication. We have made several releases of OSU INAM. The latest release is available from this website. We have enhanced our storage to be faster in real time. We have support for different job schedulers, and OSU INAM sits on one node within the cluster and gathers everything from all of the remaining nodes remotely. So with that, let me introduce like the framework. So we gather information from each of these layers, also application, and we have a daemon that's running on one node, and this daemon is responsible for remote data collection. Then we have components inside daemon for gathering port counters, fabric topology, handling the data that it's being gathered, and all of that would go to a real-time storage. Finally, it's going to be shown to the user through a web UI. So question that I get asked sometimes is like, what's the overhead of profiling? That's because I should have low overhead. And in this test, we ran 256 nodes with 4K processes of NAS parallel benchmarks. We averaged it for 25 iterations with 5-second profiling interval. And we saw there is less than 5% performance degradation. So in terms of profiling, OSU INAM has low overhead. And then if people try to add profiling sessions within their applications, we vary the number of sessions from 1 to 8, and we still see there is less than 1% overhead for adding additional sessions. So INAM gives you a low overhead and scalable profiling of your communication. Now let's take a look at some demo. One second. Okay. I think this is too tiny. So right now, I have OSU INAM running on our in-house cluster. So the first thing you see, it's how can I? 1 second, sorry. So this is our in-house cluster at our department. So this is the real-time visualization of your network topology, with the blue nodes being the compute nodes, and the red ones are the switches. And you can see the link utilization shown to you over here. So the link utilization percentage is represented here, and people can filter it based on the metric. So right now, the metric that we have chosen, it's the maximum bytes sent and received, but there are other metrics available from just like SME to receive data to like MPI collective data, and also like the capability to see if there are any types of errors from symbol to like drop packages and so on. So people can choose like, let's choose a different method. 1 second. So if there is a link that has any like errors here, you can see it would be marked as red. That's one capability. And then this is on the system level. So another capability is show this for a specific job or specific set of nodes. So for example, you can choose what nodes you like to include in your visualization and hit refresh. And you're going to see a subset of nodes. I think Mahidar show you some visualization on how to have the jobs. What I'm going to cover right now is go more onto like inside the job, what is happening. So in here, did you? Okay, let me go back. So let me, how much? Okay. So for example, for your switch, we also have a page that shows transmitted data for the switches. Is the web browser running? Okay, yeah. So, and here you can see for this switch, what is each port connected to. And if you click to expand one of them, you're able to see the communication pattern over time getting updated per user default query time. And these metrics are all shown here again. So you can see like from InfiniBand port data counters and errors if there's anything that's causing error. So you can just change the metric to, so if I choose an error one, so there is no error, and it's available for all of the ports for the switch, and the graph gets updated as you just see like every 30 seconds right now that I've chosen. Another capability that is useful is when you want to figure out, so these are all the tabs. I'm not going to have time to cover all of them, so I covered the most important ones. Is when you want to identify another capability to where is a node within a cluster. So we also have a search by LID and node. So here, if I'm just looking for specific LID and choose it, it's going to show me where are those nodes. Let me expand all of these. So the node that has the LID of 14 is identified here. And if you hover your mouse over it, you can see if there is any active job on it, what switch it's connected to, what's the GUID, and all the information there. So I think my time is up. We have another video of the capabilities of OSU INAM at the project website. That's a 30-minute that shows how are we collecting information from MPI. So if you have a black box of application, you don't know what MPI primitives are being used, you can plug in INAM and it have its global session activated, and you see how much your application have transmitted, like all reduce, how much it's all to all, and what are the algorithms selected for those. Please refer to that video if you have more questions, and I'm happy to take any questions anyone have. Thank you.
Any questions from anybody? Locally or online? No? People are getting a little bit tired to the end. Okay. So if not, then we'll move to the last presentation of the session. It will be again a tutorial slash demo of the high BD software stack. We talked